-7, -10, and -9. So for the second question of A3, they give a equation of y equals to x to the x squared minus 3 over x plus 4. And for the x, values range between -2 until 3. And using element by element operation. So as usual, we need to declare the variable first before we write down the equation. So the variable here is range between -2, -101 until 3. So the first number in the square bracket is -2 colon, and the last number we wanted, which is 3. Then we have 0.5, -0.67, -0.5, -0.4, 0.1667, and 0.8571. So for question A4, it a script file problem that we need to write. So the first question that I take is the first question is question 1. A cube has a side of LCM, and determine the radius of a sphere that has the same surface area as the cube, and then determine the radius of a sphere that has the same volume as the cube. So first thing first, we are required to ask the user to enter the side dimension. So in this case, we name the side dimension as L. So to calculate, write a code that requires a user to put their value of side dimension, we need to use this code. L equals to input, and then it will display the enter cube side dimension, and then you will put the value here. For this case, we put the value of 5, and then in this process, it will calculate the radius, which is the square root of 3 L square, which L square is the value that we given, over 2 pi, and then display. This function is to make a blank line after each cube side dimension here. You see, a blank line here is not on purpose. They appear because of this command here. And then we write the radius of a sphere that has the same surface area as the cube is the result that we have calculated here in the fourth line. And then in the next line, we write this DISP R. R is the value here. So we got 3.4549. Same goes for 1B. The differences here we use is the formula here. We just do some mathematical manipulation, and we get the same result. So for the second question, we are required to determine the length of each side, the diagonals, perimeter, and area of the polygon when the coordinates of the points are known. So these are the formula that we need to utilize in our coding, as well as the below one. So this is the diagonal of, the polygon. Each side or each edge have their unknown coordinates. So first things first, we need the user to enter which length or which coordinates they are intended to. So here is the list down for the data that we need For example, here we have x1, y1, x2, y2, x3, y3, as well as x4 and y4. So when we execute this, once we run the section, it will require us to enter the value of x1, and then when we press enter, it will require us to enter the value of y1, y2, and so on and so forth until it reaches the value of y4. So to compute the length of the sides, we need to utilize this equation in here. So we have 4s, s1, s2, s3, and s4. So we need to write down each equation and list down the corresponding x values and y values for each sides. So for the length of the diagonals, which is d1 and d2, we need to use this formula, the square root of x1 minus x3 to the power of 2 plus y1 minus y3 to the power of 2. x1, x3, y1, y3. Same goes for d2. So for the computation of the perimeter, which is the sum of the four sides, 1, 2, 3, 4, is the additional, is the sum of this. So in this case, we just recall the calculation that we have done here, and we get the value of perimeter. So to compute the area of the polygon, we can use this formula. So this we need to list down by ourselves. The next, to display the value that we have been computed, we need to use the fprintf function. So fprintf, and then in this line is at length of side and diagonal. So this is the 3f. 3f here means that type of data and how many significant figure are listed. So this f is represent float. Float is a decimal number. So 3 here represent the 3 decimal places or significant figure. So to print the side and diagonals, we again need to list down the s1, s2, s3, s4, d1, d2 that we have calculated here. So to print the polygon perimeter, we need to recall the value that we have obtained here, as well as the area of the polygon. So that's all. So for question F5 is a part where they are test our 2D plotting skills in programming in this question. So the first question is plot the function y equals to x plus 5 square over 4 plus 3x square for x is between -3 to 5. So first thing first, we need to write where the variable is governed. There is -3 until 5 with an interval of 0.01. That means they will start with the value of -3 and then -2.99, -2.98, and so on and so forth until it reaches the 5. That is the limit. Next, we need to write down the equation that contains that will calculate the value of y, which is here, x plus 5 square over 4 plus 3x square. And then we need to use the plot command. So just write down plot and open the parentheses and list down the x and y value that we need to plot. So as you can see, this is the result they will display in the figure window. So for the final question here, we need to make two separate plots of the function given, and a little bit different from our last question, first question. They used to make a plot in one range value of x, but this time there are two range value of x, which is 0 to 3 and 8 to 15. So we first need to declare a two variable, which is xa and xp. In my case here, I list down as 0 until 3 and 8 until 15, which an interval 0.1 for both range. Next, we need to rewrite the same equation. We need to make two equations. One for the first equation that will range the value of x 0 until 3, and the second equation will calculate the value of x range from 8 to 15. And then we will ask the computer to plot xa, ya, k. K is a code name for black. We use in to the color of the plotting. So this is the plot for the first plotting. K is black, so that's why we see a black line here. And then we can ask there to write the title, plot 1 for y versus x. This is the first plot, y versus x, and y label yx. So in y label and x label is the function we use to name the axis, the corresponding axis. So for y label we use y in x. X label is x only. So grid on we use is to make the grid appears. This here, a rectangular grid appear. So, and then we use a hold on function. Hold on returns plots in the current axis so that the new plot added to the axis do not delete existing plots. So, and then we use the second plot xb yb with the color magenta line here. So the title for this plot is plot 2 for y versus x. And so the label are just the same, and we need to on the grid as well here, and hold off the function because we have all on. So hold off reset axis properties to their default before drawing new plots. So that is the explanation. So I guess that's all from me, Adam Firdaus bin Abdul Rauf, for this video. I hope it will help a lot. Thank you very much. Assalamualaikum.